So today we have a special treat. We have a repeat guest on the Automated Construction Podcast, Volker, who's the CEO of Vertico. Was my first podcast guest, which really means a lot to me. It's hard to go on a podcast that has no existing audience, no previous guests to get an idea of what it might be like. So I really appreciated when you took the leap of faith in being my first podcast guest ever. And also I appreciate you now having me here in Eindhoven, the Netherlands. So thank you for making this all happen today.
My pleasure.
So let's get right into it and talk about in our last podcast we talked about what you had been working on over a year ago, and there have been so many updates since then. Can you give just a couple highlights?
Yeah, so the big highlight, I think, in your podcast, I sort of hinted at the fact that we were building a nozzle that would add accelerant at the last moment to harden the concrete quicker. And in the time since we last talked, we finished the first prototype, and we're going to market in the next 4 to 5 months. So it's done. We're really happy with the results. You saw it in the first podcast just in the background, and now you see it, just behind you. And the next iteration will be even more complete. That's one of the main highlights. Other than that, we have seen since the last time we spoke, it was really early in COVID, and we've seen quite the market pick up pretty intensely in the meantime. So it's really booming. So there's a lot of interest in printers, a lot of printer sales, a lot of interest in printing. So we're really happy to see sort of the market come back and be robust.
So for people not familiar with a two-component system, what advantages, complications, like pros and cons, comes with the new nozzle?
So the main advantage is that the concrete sets within a matter of seconds. And what this does is that it enables you to print overhangs that are much larger. So instead of the usual construction method where most walls are relatively straight, maybe a 5 or 10 degree angle over quite a long vertical increase, now we can basically do angles of up to 60 degrees from the get-go. And because it hardens so quickly, that also enables us to do much more patterns and create pretty unique aesthetic objects. That's the main advantage. Disadvantage of a system like this is slightly more complex. So it has another pump that you would require to pump the accelerant to the nozzle. It has a mixing requirement at the end, and the electronics required to sort of communicate between the pump and the dosing pump of the accelerant makes the system more complex. So the aesthetic value of the print is much higher than what you can achieve. It's more design, more architecture, but the system is a little bit more complex. And opposed to the normal methods where you don't need the accelerant in the last moment, you either do it in the original pump, where it just takes longer for the concrete to set, but because you're making bigger objects, you have that time before the setting needs to occur. So the main advantage is we're setting much more quickly. The disadvantage of that is that we have a more complex machine.
So that 60 degree overhang you're able to accomplish without any sand poured in, without any gravel, or any form of supports. Is there any other company you've seen print more than 60 degrees?
I think there are, as far as I know, 2, maybe 3 companies in the world that do a 2-component acceleration. There's Extreme in France and there's Baumit in Austria. Now, both companies have sold their technology to several other sub-companies, but I won't count those. They're not the original equipment manufacturers in that sense. We are. And then there's Sika, of course, but they have a sort of mid-system where they do a 2-component, but it's much larger. So really the system is more comparable to the Baumits and the X3 systems. And they can do, because they have similar tech, theoretically they should be able to reach similar angles. One of the things that I think sets our system apart as well is the consistency with which we print. So I'm very glad to see that the material that we use, it's a very basic material, but because it's relatively simple, it has relatively few sort of parts to it, it seems to be quite consistent in printing. And I think that really sets us apart at the moment from other printers. Besides which, one of the things we focus on heavily here is the design aspects, where we add grasshopper models and intricate designs, and we really try to push the aesthetic limits of what we can make here. So it's also our focus on the printing itself that sets us apart, as like a printing as a service or consultancy or whatever you like. That sets us apart too within that range.
So now that you've developed this new nozzle, dual mixture, dual component mix, where do you see yourself moving forward? Will you still use the old extruder with the old mix sometimes? Or what's the breakdown going to be?
So because we've developed the two-component system, if you remove one of the components, so to speak, if you use a standard nozzle, which is basically just a steel tube, the rest of the system is almost still the same. So you're still using the same pump. We use the multi-mix from Mai in Austria, and all we have to do is attach a steel nozzle to that, and our slicer will still perform the same activities for concrete printing. It's just the material mix that changes. So the material mix you use in what we sort of call a one-component mix, which isn't quite correct because the mix can have anywhere between 4 to 12 components, whatever you like. But we can offer both systems. So our simple version is the pump, the software, the communications, and the steel nozzle to do constructive type printing, and then the more advanced version is a two-component nozzle. So I see ourselves still doing both. A lot of the machines a lot of the clients we have now are R&D based. So the universities and a lot of universities, but also companies that either do R&D or want to get started slowly in the industry, and those we can offer the more basic system, and that can be upgraded to the two-component system if they want to offer the more complex things as well. So the next year for us is going to be delivering and installing several machines and putting these two concepts in the market. And after that, we'll see if we can develop the printer even further, adding new features, colors, etc. But for now, it's delivering machines and really making sure that the machine is reliable.
So this robot behind us is on tracks. What are some of the advantages of that?
The main advantage I see on the track, obviously, is the range extension. So our track gives us a capability of going 10 meters in terms of reach, but you can extend the track to 100 meters if you like, depending on what you're doing. You can raise the track in the air, so you can make a robot do even more, right? And the robot is obviously your basic industrial robot system. The reason why they're very good to use is because they're relatively affordable, especially on the second-hand market, because they all come from the automotive industry. And if you're able to afford a track as well, which is almost the same price as the robot, then you can really extend your reach. One of the things that's useful for us in this case as well is if we print several objects and we want to print more, we just move the robot on the track and we can print more objects. You can also print bigger objects, but oftentimes when you print something that's 4, 5, 6, 7 meters wide, it's quite difficult to move. So transport becomes an issue, and we don't have the facility here to transport things that are 10 meters wide because they won't fit out the door. So usually what we use it for is production flexibility, that we're just able to make more things faster next to each other.
So right now your niche is in off-site printing, mostly?
Yeah, 100%. So we spend 0% of our time in on-site printing. I think there are so many problems we still need to solve in a factory setting that we don't want to add any variables. We're already, even inside, we're already learning a lot about what sort of humidity ranges we like to work in. We're learning a lot about what sort of temperature ranges we like to work in. We're even learning a lot here about what happens when you open a door and the wind sort of blows through the space, right? So we're adding more and more sensors to gather more and more data, and we're compiling those to kind of measure what goes on in the system itself, but also especially in the surrounding around the system that you've built. And to add sunlight, rain, etc. to that, that's one step at a time for us.
Currently, what's the maximum Z height for the printer?
So this one goes 3 meters. We have one in the back that we just put on a pedestal, so that can go even higher, 3.5 meters. If you extend it up, it can even go to 4. If you want to go higher than that, either you can extend the robot height even more. There are systems. I think there's a company in the US that does steel printing of rocket fuel tanks or rocket engine. I don't know, some giant.
Relativity space.
Yeah, that's the one. They put their robot like on a ridiculous height, but they're able to work with that because they're doing a single object. So that's possible. But if you want to do 4 meters high and 4 meters wide, you start going to the range where gantries start becoming more interesting.
Yeah, they just raised $500 million.
Yeah, give me some.
So you have some pretty incredible designs, especially when it comes to, I guess, the layer geometry. This all comes from, like you mentioned, Grasshopper in Rhino and parametric design. I know you made a key hire that really advanced your abilities Vertico's abilities to experiment with these designs. Can you go into some details on that?
Yeah, sure. So when I started in 3D concrete printing, we still worked with Cura software to run the robot, which is a bad idea because it's not made for running robots. And I saw in the market that many companies, similar companies, were using Rhino Grasshopper, so I decided to move to Rhino Grasshopper. So we made a slicer in Rhino Grasshopper that works for robots, it works well. One of the main advantages is when you use Rhino, you can design in Rhino, and because the slicer is also in Rhino, there's a very good sort of connection between the operations that you're doing. I was lucky enough to hire somebody from Delft who in his master had a lot of experience with Grasshopper already. So I'm slowly seeing students graduating with skills in Grasshopper. If you're in the market, if you want to find a job in 3D concrete printing, you will see a lot of, or digital manufacturing for that matter, you will see a lot of job openings that require Grasshopper, right? Because it's just a nice skill to have. Using this software, you can sort of we generate a code structure, so X, Y, Z. And if you want to do this on a gantry, it's relatively simple because generally they're 3 axes. So it's X, Y, Z, and it's what we call 2.5D printing. But when you use a robot, you have your 6 degrees of freedom, or 7 in this case, because of the track. And then you need to also incorporate the angle at which your tool is parallel to the printing surface. So if you want to start making objects that are curved, you need to do another more complicated step in Grasshopper. You need to start defining not only X, Y, Z, but you also have to start defining how we orient the tool. So this logic, it's quite complex, but once you get the hang of that, it's not the logic of the robot or the logic of the XIZ, that's the main issue, but it's the logic of the object yourself. So you start designing objects that are more and more complex, and you have to create individual code bits for that specific object. So you have to, first of all, if you're the designer of the object, it makes it much easier to then create the logic of the code, because they communicate. And that sounds quite complex, but if you know how to design in Grasshopper and you know how to slice, that connection becomes logical. So that's one of the reasons why just uploading a model to a random slicer won't give you the results that we're able to attain. Because if you want to make really complex objects, you need someone that's able to do individual slicing, that's able to do sort of custom slicing on these things. And one of the things we do now that you don't see much in the market yet is we really take advantage of the 6 degrees. So we're now doing printing where we do variable layer height. So we have a complex print coming up where we start at 4 millimeters, and at the end of the object, which is 2.5 meters further, we go to 20 millimeters, and that creates a really big curve across the object. And we can do that by varying the speed. So if we move faster, we have a thinner layer height, right? If we move slower, we're getting a fatter bead. But this speed advancement, you have to calculate into slicing as well. So it becomes quite complex, and you need guys that are deep into logic to be able to program these more complex items.
So to dive a little deeper into parametric design, there's a print behind us with a kind of, it looks like a double weaved pattern.
Yeah.
But your designer was explaining to me there's actually a straight line in between those.
Yeah.
How frequently does the model in Rhino, the way it appears, deviate from the way the print actually comes out?
Potentially every time. So what we do in Rhino is we create the model, and you'll see sort of lines in space. So you can look at the object, and the geometry is what you're going to get. But these patterns that we create, they're actually, if you look basically at them, they're not as complex as they might seem, especially the ones that you've seen on, or that you're pointing to. If you create a cylinder and you say for every first line is a circle, but every second line comes after every centimeter comes out a centimeter, and every third line comes out on every odd centimeter. And then you create a third line, which is a circle, and then the fourth line is 1 centimeter out, and the fifth line is 1 centimeter offset. It's quite simple. And if you give that a twist, then you get this beautiful twisting pattern. So that logic is relatively simple, right? But when you see that in digital lines that are just straight, you can't exactly visualize. So what you need to do is, in a digital environment, you need to create a simulation where the lines are actually thickened. So we can do that, and that gives us an indication of what the pattern is going to look like. But honestly, one of the reasons why there are so many pattern sort of experiments here is just to see what looks nice. Because you will never see how nice it is until you've printed the actual object. So we just keep doing more patterns, keep experimenting with, okay, what sort of thing looks nice, what sort of thing helps us out. And that big one actually was done real quick, like on a Friday afternoon. We thought, what are we going to print? We want a column. And he drew up the code real fast, and we decided, let's see what happens. And this great sort of repeatable, smooth pattern came out, which we like now, and is part of our repertoire.
Was that accomplished all in one go, or was it printed in sections?
No, that's one go, yeah.
And so what's the height of that? 2.5 meters?
Yeah, around about. Yeah, I would say about 2.5, yeah. Yeah. But again, these types of columns, they're experiments just to... I'm convinced that one of the applications we're going to see in the near future is columns, because we can use them as lost formwork. They're relatively simple, they look stunning, and if you put 50 columns in a building and they're all different and they're all the same price, even though they're all unique, that's gotta be interesting to architects and designers.
Certainly. The market for 3D printing is frequently looked at as like a solution for affordable housing or like cheaper products, but the capabilities and the one-off design seem to lend more to higher end, more custom objects.
Yeah.
How can we change the perception and desire of 3D printing from the public from an unrealistic expectation of affordable housing, because it's not there yet. It might get there eventually, but it's maybe like flat screen TVs where they come out and they're super expensive in the beginning,
yeah,
until the technology reaches a scale where you can produce 1 million bulbs in each TV for like $200 at Walmart,
yeah,
or something like that. But how can that perception be adjusted?
I think it's tough, because in order to influence that perception, you have to have an audience. So potentially conversations like these will adjust the market a little bit. I think the main way we can do that is by producing more and more objects. I think the more projects we produce that showcase the greatest advantages of the technology, the more the perception will be, okay, those projects are successful, therefore they must have some benefit or some business case behind them. So what I did, what I keep doing in this industry, I started in plastic printing as a hobby, right? And I really like 3D printing as an industry, so I followed the industry quite closely. The holders report and all these, these information that came out, and I just looked at it. I looked a lot at like, what are the trends, what's coming now, what's popular, and what advantages are cross 3D printing, cross steel, clay, plastic, whatever you name it, or powder based or FDM based or whatever. And what I noticed is obviously similar advantages, key advantages coming up. So one of them being form freedom, obviously. but another one is rapid prototyping. Another one is the reduction in change costs, right? So if you want some change done to your design, because of the rapid prototyping, you can do the change more quickly. Another one is the digitization, so the connection with the digital. But another one as well is lead time reduction. So because we're able to make a digital design and send it to the printer, we get unique objects back quite quickly. The question is, can these key advantages be taken advantage of in the housing market, right? And I haven't been convinced of that yet, but the more I look at it, I think, okay, maybe the lead time is a big change for the housing market. Maybe the digitization is a big change. Maybe the reduction in failure costs is a big change. I'd love to see data on that from printed house projects. And that kind of information is going to help us as well to sort of define, okay, where are the limits of what we're doing right now, or where are the potentials, right, of what we're doing right now. So I think more information from the actual housing projects, where were the key advantages, what were people most excited about, and more projects from the 3D printing side that we're doing to showcase where the business cases lie that are going to be business cases because they utilize form freedom, digitization, rapid prototyping.
Yeah, it makes me a little curious how advantageous the rapid prototyping is with especially like a large concrete heavy object that's not going to be moved for a really long time optimally. Yeah. What situations is it important to get that object in 1 day or 2 days rather than 1 month?
It's a good question. So when I did a lot of plastic printing for the automotive company I worked at, my challenge was to get the engineers on board, right? So in automotive, and obviously for these type of product, engineers are the key users. And one of the ways I convinced them that 3D printing would be big business is by I did a race, and we would both design, we would have an object, and I'd say, you do it in the traditional method, and I'd do it in the plastic printing, and whichever one comes in first wins. So that's a way, like a fun way to kind of show them, look, this rapid prototyping is helping you now. In concrete, from our design point of view, we still have a lot of people that are skeptical of the entire business, right? So I have clients now that say, can you print my logo? That's something we get a lot of requests for, right? And I say, sure. And within a day, we've got their version of a logo. And even though the final design probably won't include their logo, they understand, hey, look, it's fast, it works, I can see it, feel it quickly. Same goes for when you start, let's say you want to design the 50 columns I'm talking about. If I can deliver you one in a week, that will convince you of the fact that, hey, there's reliability in the technology, the design is nice, I can look and feel, I have the look and feel in front of me, maybe we can do some experiments with coatings or whatever, so that it just brings it closer to people that don't understand the technology yet.
Yesterday we recorded a separate video walking around the facility and looking at many of the different objects they printed, so we'll get a closer look at those in that other video. What objects do you see becoming some of the more attractive for consumers in the short term?
Right now, the columns, I think, as I keep mentioning, those are in the short term because we can do them already, right? Similarly, a small column looks quickly like a flower pot. Flower pots are something that are now popular as well. People want them. Entire office building, interior designs, that's definitely going to be quite popular. We see the same application for outside, so horticultural companies that want to have unique gardens, etc. So we see the quick wins are gardens, interior office design, columns. Those are things we see that are quite popular. Another thing that we get quite a few requests for are reception desks, which are tougher because they're quite large, right? But those we get quite a few requests for as well. So I think the objects that are easy, that are within reach, are the ones that have no constructive requirements yet. Even though we can do them, the market just isn't ready to accept them yet. and at the same time, so we kind of have to push the material first and the technology, and then slowly they will trust and build more constructive elements.
Yeah, I think people want things like reception desks and maybe flower pots because it's so unique. It's an eye catcher. People are naturally drawn to things that look like one-off that they've never seen before.
Yeah.
So I could only imagine that once some more of these sell and more people are getting exposed to it, the desire for their own custom one-off objects will inevitably increase.
Yeah.
They really are really unique, especially the parametric design. It's like almost like a mind game or something. The way they like bend and curve.
Deception.
It's things you haven't seen before because creating the formwork for that would just be such a challenge.
Yeah. Yeah, and we see the same in one of the first projects we did was with the University of Ghent, the topology optimized bridge. We recently did a column for the University of Liverpool, which was again this topology optimization, and the potential there. So the idea is that you have a computer design your object based on a set of parameters, one of which is I want this much weight to be carried by the object, be it a bridge or be it a column, and then I want a minimum of material to be used. So a computer will start removing as much material as it can while retaining the strength. So you get these very organic objects, right? This form freedom that we talk about is really in there. And as you say, making molds for that in a traditional sense is going to be expensive. Doing them with concrete printing is much more affordable, especially when you have many different optimizations, right? So the idea is that every tree is optimized for its environment, and none of them are square. And none of them have more material than they require because that would be detrimental to them, right? So in that sense, it's a biomimicry. We can take notes from nature, but you get organic designs, you get round designs, you get efficient designs, and these things this is really, once we do the unique parametric designs, the flower pots, etc., and then we start doing constructive elements because we can. Once those two are settled and we can merge the two, then we start getting optimized designs, optimized bridges, and that's really huge potential of what we're doing in this market when we can do material reduction and optimization. But we need the pillars to be ready first, the design freedom, the production reliability, and the sort of trust in the technique for it being constructive. Once the market settles in that, we're going to have unique objects that are actually constructively optimizing things in a parametric manner.
So one of the things that's maybe less discussed in this space that people are very curious about is the cost. And I was wondering, could you give an idea of the cost per ton of your material?
Sure. Our basic material costs around 500 euros per ton. We're not in the business of selling material. If you buy a machine, you have our material supply. We can ship it to you, but I'm not really in the business of shipping sand across oceans. So we encourage clients to find local partners that can make the material for them, even though we don't mind sending it to them at all. But it's not our business model. So I know there are machines out there where the business model is to either lease the machine and be stuck with a particular material. For us, material is not required. You use whatever material you like. If you have a material of your own, we can test it here as well to see if it works with our accelerant. But basically, with 500 euros per ton, you have your basic mix.
And if it's 500 euros per ton for just the mix alone, if you print an object, is there like an expected overcharge, or is there like a cost per ton of printed material that you could estimate?
What do you mean?
So let's say you print 1 ton of material.
Yeah.
And for a product for a customer, where would what would the cost be? Like, could a customer do a rough estimate of a print cost based on that?
Sadly, no. For the same reasons that I kind of sketched before. If we're doing an object that requires a lot of optimization and print pattern, that's where the costs are. So, for example, we had a client in the US that wanted quite a large sort of basin, and it wasn't simply a round object, but what he wanted was starting with a flat surface, and it would sort of taper off to like having undulating pattern, and then it would level back off to having a straight top. So great design, not necessarily easy to design from a rhino grasshopper perspective. So that's something that we then did and managed to print first time right, so we're happy about that. But we had to spend some time figuring out how that logic would work of speed changes to get the layer height the right size for the object. After a lot of practice, we're pretty good at that, but that's usually where most of the time is. So even if you have a 500 euro per ton material, you can easily work out how heavy your object is going to be and work out what the material cost is for that object that you're printing. But there's no way to say that an object itself will cost a factor of 1, 2, 3, 4, 5, 6, 7, 8 of the material cost. It's sadly not that simple yet.
When you move up from the standard material and go on to the dual component material, what's the price change?
That's approximately the same. So accelerant is not that expensive, luckily, right? That's the more expensive components are in the initial mix itself. So that's the the viscosity modifying agents and the actual cement, and the sand is not free either. The water is generally all right, but the rest of it, that's where the expensive components are. So the accelerant itself is not where the costs are, and that remains approximately the same.
Do you know what portion of the material is sand? Because sand is kind of a questionable resource.
Yeah, but I'd have to look it up. I can't give you a figure right now.
Sure.
I'd have to look it up.
What about the price of the printer if somebody wanted to buy a printer from you?
So we have because we have a robot setup, we're quite flexible in the design of the printer. So the smallest one we have is an R&D printer in which we place a small robot on top of a steel frame, and we can actually house the unit in an 80 by 120 space, and it's really designed for laboratories, universities, because they have space restrictions, right? So this setup will set you back approximately 50,000 euros, depending a little bit on what options.
And give you what kind of print volume?
The print volume will be, the printer has a reach of approximately 1.50 meters. So a printer has a reach that's obviously restrained because it turns from one axis. So you can reach 1.50 meters in a circle and up as well. So inside there, you can design a box.
So like a 1.50 meter radius.
Yeah, exactly. Yeah, we can do it with a slightly larger machine, but as I said, ABB offers a lot of sizes of machine. So you're so flexible that sometimes it gets hard for customers to decide which machine they want. But the small machine, 1.50 reach, is approximately 50,000 euros, depending on which options you have. Then we can do a machine where it's simply a stationary robot with the pump system that will set you back with a one component nozzle that will set you back approximately 140,000 euros. Then when you add the accelerant nozzle, that's when it starts getting more complex, and that machine will set you back a minimum of 200,000 euros. Then on top of that, you can buy a track as well. You can buy the newest of the newest robots from ABB. You can get safety curtains. You can get light curtains instead of safety fences. You can get a silo. So you can go. Sky's the limit on how luxurious you want to make the setup. But when you're looking at an accelerator nozzle, there's a minimum of 200,000 euros that you're looking at.
Okay, so you touched on the mixer system. The mixers are a place where there's maybe the most variance in how different companies are solving that problem, just because the printer or the mixers off the shelf aren't equipped necessarily for printing. So every company needs to make their own modifications to the mixer. How have you developed your mixer and the current setup that you have here?
It's always a good question. When we started mixing, we bought a dual mix, an MTech dual mix, and we didn't have the funds to buy a new one, so we bought one online from Germany, and it was actually the original MTech dual mix, so it had no frequency drive. So we had to build a frequency drive on first. Someone did that even before I joined the project we were doing. Then when we first started, we couldn't figure out how to do a continuous mix. So we had our basic material, but we couldn't figure out how to make it come out consistently. So what we would do is we'd mix it by hand and we'd throw it into the dual mix dry compartment and we'd just pump it through. Then we figured out that if we just buy a smaller pump, if we're hand mixing and we use a smaller pump, we reduce cleaning time by 70%. So many of the first projects were done with a really small pump, just for ease of use. Then we took the time to figure out how to do continuous mix on a dual mix. So we figured that out. That was the basis for our 2-component nozzle, because when you're doing 2-component printing, you have to have a continuous mix, because the material needs to be consistent. Otherwise, your consistency of your print is going all over the place. So consistency is key. One of the ways we improve the dual mix as well is by adding a digital water flow meter. So the ones they have is hand set, which can work, but we decided to move to a digital version. And what we did is we programmed the material supply such that we'd count the revolutions of the motor and measure how much of our material came out with that motor. And these two figures we wrote a bit of software for the dual mix. We sort of ripped out all the electronics, wrote a bit of software to set these that they match perfectly. So we always have a consistent material dry volume to water ratio. In that sense, our machine became connected, so we could put a USB in and program it from our laptop. And then we kept sort of improving the machine, and then we came across the My Multimix and basically saw that they had already included the improvements that we had sort of started making as well, but also have 50 years of experience in pumping. So the machine is built for what we were basically accomplishing ourselves. So we decided to switch to them. Now we work exclusively with the My Multimix pumps, because we know why all those bells and whistles are on there, right? If you start printing, you don't necessarily need this machine. I recommend if you want to start printing, mixing by hand. We did it for years and it worked perfectly fine. We sell the lab scale printers with a hand mixer as well, because that's what you want to do when you start printing. But in the bigger machine now, that we measure humidity as well, outside temperature. These things become very important when you're printing at this level.
I can imagine with the mixing by hand, it's a little more difficult maybe to get the material mixture right with the right amount of water, right amount.
Yeah, I can imagine why you'd say that. And in my experience, we got it down pretty fast. But one of the main mistakes I still see in other concrete printers is using a mix where you basically buy sand, buy cement, and buy whatever agents you want to put inside. And they have sand that's that's theoretically dry, but they will measure the water content by putting it in the oven and seeing the difference. And then they will compensate their water level in their mix when they're doing it by the amount that they measured, which we started like that too, and theoretically that's correct, except in practice, if you have 1 ton of material, the water sort of saturation is not the same throughout the pallet. So on top it'd be a little bit drier than on the bottom because the water will settle, right? So even if you measure some of the water content from the top, by the time you're mixing a little bit lower, you're having changes in your consistency. And that's a mistake I sometimes still see. So I encourage people to buy industrially dried sand, which, if you're listening astutely, not exactly good for the environment to also industrially dry your sand. So there are certainly issues we still have to solve. But for your consistency, you really need it. And even mixing by hand, our material is based on dried sand. When you mix our material by hand, we don't notice a consistency change if you've measured your water properly. Yeah.
So when somebody buys a printer from you, what's the level of support you provide for figuring out the right mixture, getting started with some of the designs?
Yeah, it's a good question again. We are not material experts. We are experts in quite a few things in concrete printing. We leave material to the scientists or the concrete experts or the specialists. Our material we know well. We designed it together with a company from the Kamp and their material scientists, so we know how and why our material works. But if you want to develop your own materials, that's not where we can support you best. You get our material mix when you buy a machine, but if you want to start experimenting with shrinkage reduction agents or whatever you like, that's something that you'll have to learn by doing. In terms of support, I think it's very important for our machines or everybody's machines to be implemented for them to be successful. So I think it's extremely important to have post-sales support. I want my clients to print really nice things. It's not only good for our reputation, it's very good for the client and their project, who have spent a lot of time and money, investing in this opportunity, but it's also good for the market, right? If people see that clients are able to print really great stuff with relative ease and are successful, that's what's going to drive the development of the market. So we focus heavily on that. We have post-sale recap trainings to get people back up to speed, lessons learned. We don't shy away from, if we have some type of upgrade, to send it to our customers after the fact. If we change some way or we find out some bolt is better here or some extra attachments, send it to the customer and help them out too. And likewise, if they find some smart way to fix our machine, please tell us, then we'll try to integrate it in our machine as well. So in this phase, I think it's really a back and forth. So I read this thing online that said, I'm not in sales, I'm in relationships. And I thought that was really cheesy, but it's not untrue. We want to build relationships with our clients. It's not about sending a machine and running away.
Yeah, especially when it's such a new technology and there's so much potential for them to give you advice, recommendations from their prints, features they might want or could add value.
And it's not easy, right? So I'm very sympathetic to the struggles of everybody in concrete printing because, I've been living that struggle for years. We've actually sold our accelerator system twice now, even though it's not on the market yet. So there are brave customers out there that invest in systems, be it a Cobot, be it an Icon, or be it Sika, be it Baumit, our system, whatever, that understand that they're test customers, right? They're early adopters, right? They're simply early adopters. So I'm very happy with these clients that understand that yes, we have a system that can make extremely impressive prints, but at the same time, we're going to keep improving our machine, right? It's not the finished product. It's not a car that's been developed for 100 years. We got some time to catch up.
Yeah, I mean, even with that, they come out with a new car model every year, and then every 5 or 7 years, completely reinvented.
Yeah, exactly.
So,
hopefully improved, right?
Yeah.
Hopefully better.
Hopefully there's no end to the improvements that can be made.
Yeah.
But there is, I think what you're really getting at is the diminishing marginal return. So in the beginning, they're improving a lot, and every time it's much better, a little less better, and then eventually you're down to just incremental improvements.
Yeah.
Where they really need to tap into consumerism to keep selling the.
I think I fully agree, and we talked about it in my experience in the automotive. I see that now, and from a sort of sustainability point of view, you sort of hope that as a society we could say this car is good enough. Let's stop building more different, slightly better cars that have cameras for mirrors where mirrors suffice. Why do I need a camera in the mirror just because it looks more fancy? At some point we should say, we're happy with this and let's focus our effort elsewhere, all these brilliant engineers. But sadly it's not how the world works. But in this case there's room for improvement, right? So get those engineers from automotive to come here and help us improve in greater leaps and bounds, right? Let's go.
Yeah, I mean, what you're saying would be bad for your old friends at the auto plant.
Yeah, exactly. But they're still friends, but I invite them to come work for me.
Yeah, so we talked about the price of the material, the printers. How many printers have you sold this year, and how many have been shipped so far?
So we're looking at our 7th machine sale. I don't know in how much detail I can go about that. One in the Netherlands has been installed, one has gone to one of the Scandinavian countries, and I think I'll leave it at that for now. Hopefully soon you'll start seeing our clients posting their own sort of images of what they've been doing. I look forward to that, right? It's a new phase for us as well to start hopefully seeing more posts from clients than from us. So we are really riding the wave now because it's a very popular market. The RFQs, they keep flying in.
Is there anything you could advise somebody with an RFQ, request for quote, before reaching out to you to lubricate the process?
So what I've noticed is that my first question when I get quotes, let's talk about machine quotes, not printing as a service, right? So just machine quotes. The first question I generally send back is, what do you want to print? Because concrete printing is not one sort of homogeneous technology. What do you want to print? Do you want to print houses? Do you want to print for R&D purposes? Do you want to print for structural purposes? Do you want to print for design purposes, right? So what do you want to print? If you want to print for design purposes, if you want to reach, designer objects, columns, etc., you need a two-component system. There are only a few suppliers. One of them is our machine. If you want to go for R&D purposes, go for, in my opinion, go for a robotic solution, because you don't need the volume that a gantry can give you. You need to have enough volume for you to do structural analysis, right? And you can print a house that's, whatever, 10 by 10 by 4, but you can't do structural tests on it because it's too large. You can print a wall on a robot, and it fits inside the compression machines of the universities in your area, right? So robots work for that too. In structural analysis too, right? We deliver, the basis is the same as what a gantry printer uses for printing. It's only the motion that's different, right? So, or do you want to print houses, in which case a robot is limited. And there are ways to make a robot mobile. They exist, but what I've seen from the market, the more successful housing projects are gantry based. So ask yourself the question, what do I want to print? And if you want to print 10 houses in a row, for which we get a lot of requests, don't go for a robot, go for a gantry.
So looking forward to the growth of Vertico, what kind of key partnerships are you looking to develop, not just with your clients, but other partnerships that could increase your business?
We're on the pump side now. As I mentioned, we do a lot of work with Maya. I think they have a lot of experience in pumping, and they're interested in, they focus on 3D printing also, so there's a good partnership to be had there. We're quite strong in the robot area, so we have a supplier here of second-hand robots in Iris Robotics, but also ABB for the new robots, so they're very reliable suppliers for the hardware from the robot side. The software we're also strong in, so we have our own Rhino Grasshopper solutions. We do a lot of training in both robotics and software, so that's something we do in-house. One of the things that I mentioned earlier is we're very open to developing new materials. So if there are material suppliers that's their area of expertise, we're open to using our equipment to test out their materials, and perhaps even sell their materials along with our machines if it suits a specific purpose, right? So it's the material side we have support, but we're open to experimenting for other suppliers. Robotics, we have a lot of expertise, and geometry as well. For the pumps, we work with the Maya. So we have the whole package, but it's the material side, we're open to working with different suppliers.
Is there any room for collaboration between the competitors in this space, other printing companies, other people who maybe bought printers from other companies? What we see sometimes is some printers that have been sold are not as strong on the software side, so we see requests for only our software to run other printers. That's interesting. I think that I developed, along with a company called Y-Linus and the University of Saxion, we put a free version of our slicer online to kind of help out people that are starting in the industry that they don't have to design their own software, but they have at least a basic hurdle covered. So, I recommend people that are starting to go to slicerxl.com and just try some stuff. So there's potential for collaboration there for companies that are not as strong in software. We get quite a few requests from gantry developers to develop software as well, so that's what we're doing now too, because the difference isn't that large between the slicing software for a robot or for a gantry machine. It's still XYZ coordinates. We work together with several partners worldwide, where we sort of we send each other RFQs. So if I get an RFQ for printing a house in Canada,
I tend to send it to Ian Commission of Tom, because geographically it doesn't make sense for me to do the work here in the Netherlands and then send the house to where they also have a location, right? So sometimes we work, in the industry, we work together to kind of try to sort all the requests that are coming into the market. I think that's a good thing to have. I noticed that one of the ways we can work together more is having more of these panel discussions. So sometimes we do panel discussions, people, they host this, and that gives us an opportunity to talk to each other again. I think COVID had one of the worst, the setbacks for us, or one of the setbacks for our company in COVID was that the digital concrete conference that was going to be held in Eindhoven couldn't be held physically, and that would have been a main place for us to meet competitors, but also clients and also research institutes. So that disappeared on us. So again, I encourage universities to start up more conferences so that we can meet each other in person as well. I think that's the kind of thing that helps collaboration.
Yeah, definitely. And what about the, you've done a really good job of kind of being recognizing that it's a blue ocean currently in the market, and it's a new emerging industry, and there's so relatively few competitors in the space compared to the addressable market size.
Yeah.
So there aren't really, people aren't fighting over customers yet, and regionally most of these companies are serving either their country or their region, and so there is room for you to share RFQs with other companies when it's more fitting for them. How can has there been issues with other companies kind of not recognizing the blue ocean strategy, maybe seeing a red ocean before it's there?
What does that look like? What do you mean by that?
So a red ocean is when the market becomes saturated and people are really fighting tooth and nail to win customers.
I haven't seen that as such, but maybe I don't get to see the fight because it happens, at the client side when the tenders come in. Sure, we've had tenders where I know that competitors of ours are also involved. That I have seen. Generally, I mentioned we sometimes send RFQs, to partner companies of ours. That has, first of all, it has the benefit of building a relationship with a competitor, right? And it's a blue ocean, as you say, it's a small space, so it's good to have this relationship for information sharing, knowledge sharing. That's good, but it's also to the benefit of the client, because you want them, in the end, you want them to do a successful project, right? So they're likely going to end up there anyway. So I hope that even when it becomes more of a red ocean, there's still the sort of hoping that the benefit for the client stays. But yeah, you never know how competitive it's going to get. In terms of who's selling to where, what I've noticed currently is that printing is a little bit more local. So yeah, we sent prints across the ocean to California, but it's easier to sell columns and large heavy things to more regional spaces. But for printer sales, that isn't the case. So we have a worldwide market. And if a client wants a particular machine, then the local benefit isn't necessarily as strong anymore. Then the technological aspects become interesting. So in the US, for example, it's an interesting market because it's such a large market, but they're lagging behind a little bit on the European market in terms of numbers of printers that are operational and that have been sold. So the technology is a little bit more advanced here, and especially in the Netherlands as well, where there's 4 companies doing this in the space. So we sell machines to the US as well, because we're if you want to get in ahead of the curve, then these machines are obviously they give you a head start in the industry, right? So in that sense, globally, I haven't really seen any red ocean. It's really what's the best machine I can buy for me. Then we get the support, and with Zoom and everything, so much is now possible from a distance. With printing, yeah, it's a little bit more local for sure.
I guess the investment market, like venture capital, investment banking, they've in the past years past decades kind of overlooked the construction sector, but now they're picking up, recognizing that technology has advanced to a point that many existing technologies can be either combined or just implemented in the construction world. Would you be open to accepting investment from other groups?
I think yes. I think investment is necessary for scaling. So naturally, it's good to keep as much of the company in-house as you can. But if you really want to accelerate, you need capital, right? And you've got to get this capital from the market, be it in convertible loans, be it in simple bank loan, or be it in equity. If you find the right partner, I think they will accelerate your venture. And it's just how the world works right now. If you want to find that kind of sum of money, you need to be willing to part with equity. And I'm perfectly fine with that. We see now that we are ready for the scaling up of our technology. Our prototype is now going to market soon, right? We're almost ready to announce. And after that, you want to start scaling up production. Because I get so many requests now for, can you do 300 hours for this job? Can you do 200 hours of prints for this job? And I'm working out how many weeks we have to spend on that. We need more machines. So it's time to scale, and I think you do that by getting capital investment. So we're open to that. The market is very different here than it is in the US. You know, I'm always somewhat envious of the 40, 50, 60 millions that are thrown about. Or the Kateras of this world, where we're talking hundreds of millions, but that's a whole other bizarre story. The climate's not like that here, but I think it's very relevant you find the right partner that understands your business model. So I'd rather wait and find the right partner than accept any money that comes in flying.
Would you prefer the partner to be a silent partner that just accepts the quarterly reports and doesn't have much input, or a partner that is involved in some way in the business?
One of the main advantages of a partner that's involved is just the amount of experience that they have. You know, when you grow this fast, it's always beneficial to learn from the experience that these companies have. So I would like to see a investor that's involved and or has experience in other similar digital construction techniques, or at least a technological investor. I think if you get a pure software investor here, you're going to have a bad time, to put it that way, because they expect different results, they expect different cost structures. If you have someone with a construction experience that understands the potential, that's excellent. If you have someone from the robotics or hardcore technical experience and understands how to scale technical environments, that's excellent too. And I think the networks are amazing that these people have. So yeah, I'd rather have someone that has knowledge and is involved than simply is on the bottom line and expects my quarterlies to be 10xing.
So is there an ideal amount that you would like for the next round of investment, and how would that be spent? Like you mentioned scaling. Scaling requires some investment.
Yeah.
What would the capital expenditure be, and where would it be located?
It's hard to say now, because it also depends on the type of investor you're getting in. So you can have investments to stay afloat, you can have investments to keep your cash flow. These are things we don't have issues with right now. You can have investors that have already a lot of the capital available. So let's say, for example, one of the ways we need to scale is by moving to a larger facility, right? We have a lot of space here now, but we would like to have an overhead crane for just easier transport. We would like to have a better temperature-controlled environment than we have here. So you start scaling in terms of warehousing. And if you find an investor that has a nice hall to sit in, then it's a totally different sum of investment than if you're going, straight cold into, I need several million euros to build my own housing. So it depends on who the investor is. We're not in need of capital injection, but it is time for us to scale.
If somebody has listened to this and become like somewhat of an educated buyer, what's the best way for them to reach you and either do an RFQ for just a print or to buy a printer?
As in potential clients?
Yeah.
Simply email to info@vertico3d.com. It'll come in and we'll sort, what's required. We react mostly within a day. Again, with the question, but what do you want to print? That's usually the first thing we say. And when it's a print, and we talked about what kind of questions you get from machines. So basically, what do you want to print? And when it's prints, there's a difficulty of suppliers, often designers, delivering their own objects and then being disappointed at what the potential is. So I encourage people that want to design for concrete printing to contact us beforehand, to say, look, this is what I want. What are the sort of parameters that we're looking at? It'll make for a more successful print.
What other details can they include to speed up the process?
Timeline. When do you want the machine by? It's very important. A size of prints you want to make. What kind of objects do you want to make? Are you into construction or are you into architectural design type printing? What kind of volume do you want to be producing? Or do you want to buy the technology to, you have the runway to kind of move along with the pace of the market, which is fast, but you have the time to learn. Those things are interesting. And what's also important for us to know is, do you have any robot experience? If you have robot experience, it goes a lot faster. If you don't, then we train you in robotics first, so that you have the basics under control, and then we move on.
What are some red flags that people kind of send in emails that lead you to maybe like not replying to that one or like moving to the next one quickly?
I think I've replied to every email so far. The ones I maybe don't reply to are people that are extremely impolite. which just bugs me. There's no point in being impolite. Then that's always weird to me. Like, what? They just send one-liner emails saying what's the price. That tends to annoy me. Other red flags are sort of the people that expect the technology to be the magic bullet, right? I have a plot of land. I want to print 1,000 houses by next January. How much does it cost? This is a bizarre question to me, but apparently people think it's possible. I'm glad people still think miracles can happen, but don't email us about it that we can't do it. So that's another major red flag. I guess another red flag is what we see is when just random designs come in. They say, can you print this length? Can you print 35 meters at a time? It's just. Those are big red flags. Like, okay, these guys don't quite understand why they're in the market yet.
Yeah, the vague how much do 1,000 houses cost question is particularly bizarre, because you would think somebody who wants to embark on some project like that might have some construction experience.
You'd hope, right?
Or some real estate development experience, in which case they would know that construction projects, even if you estimate everything the best you can, sometimes frequently go over budget, go over schedule, and the costs are also variable. Anybody who's done even a one-house development would know that the regional costs of MEP, roofing, finishing is all super variable. So, I mean, I would imagine an educated developer or a general contractor would ask a question more like, what would the wall cost be? What would the printed wall cost be for 1,000 homes? And still, that's a challenging question with a lot of like vague questions, like what's the size of the wall, how much insulation do you want?
And my advice there would be as well is the companies that are in 3D concrete printing are generally posting the state of the art that they're printing, right? The buildings and the architecture, etc. If you then expect the machines to deliver 10 times what you've seen in the market so far, you're gonna be disappointed. Right? If you've seen one house being printed, which is the top level of printing in the world, if you expect 15 of those in a month, you're going to be disappointed. So try and see what the greatest potential is out there now, and sort of gauge that and build off that. Many of the clients that I do like, what I really like to see, is there are a lot of clients that are cognizant of the fact that they're entering the market. right? So they are in an innovation sphere and they're preparing themselves for what's coming in the construction industry. These are often concrete suppliers worldwide. These are other companies in construction, and they see, okay, we're going to move there, and we know innovation is necessary in this fast-moving world. This is an area that is clearly a potential area. We understand we're coming in relatively as an early adopter, but nevertheless, there are already quite a few machines on the market. We're going to start slowly. So we're going to evolve ourselves early so that our organization learns what the potential technology is. Those type of clients are the most successful. So these are, when they understand that, our smaller R&D printers are very popular amongst these clients. The capital investment is relatively low, but the learning is really, really high. So if clients understand that they need to innovate in their organization at some point and at some pace, these are the guys this is where the green flags come in. You know, we think, okay, these guys get it.
So are there any unexpected niches that have emerged which concrete printing can fill?
I think we talked about it, that several years ago when I started 3D concrete printing, a lot of my friends and family said, oh my God, flower pots. And I thought, no, there's so much more we can do with concrete printing than just flower pots. And then now, once we have this parametric design, I think, oh damn, we can make really nice flower pots. And there's going to be market for designer furniture. There's going to be market for designer pots. There's going to be designer for horticultural exploitations and whatever, and entire office buildings interiors. So I guess they were right. This is a lot more potential than I had guessed to begin with, right? So as I mentioned, I still think that the ultimate potential of the technology is more the material reduction, optimization, topology optimization. But what I've learned is that, again, the pillars have to be stable before the market can facilitate the ultimate sort of application. If we have to make a lot of flower pots before that time, great, so be it. We improve the technology, we improve the software, we improve the understanding, the awareness, we strengthen the pillar, technology is the same thing, and then we move on. But so the future potential is really in that. The current potential is in more, for the more risk averse. So that surprises me a little bit, that market is booming that much. That people think, hey, that's exciting for my interior projects. That excites me. It surprises me a little bit. Luckily, it really works well with our tech.
If we fast forward 10 years, what major changes do you think will have come into the concrete printing industry?
I think speed will increase a lot. I think the number of constructive elements versus non-constructive elements will tip the scale. So we'll start seeing more applications where we can use them in construction environments. I think we're going to see more exciting designs in terms of this optimization that I'm talking about, material reduction. I think we're going to see quite a few bridges being made. I think that's a good application area. Those are definitely projects I see happening. I see architecture getting on board with these columns and these exterior-interior design aspects, so utilizing the form freedom. One of my goals with this as well, one of the reasons I like 3D printing and I like architecture is to move away again from the straight lines and start doing the more interesting architectural aesthetic elements. I think there's a great potential there, and the technology is the key to unlocking this potential. So I think we'll definitely, once it becomes more mainstream, see a lot of architects doing pretty amazing projects in that space. So I'm really looking forward to that. So I think there's topology optimization in bridges and maybe some constructive elements columns, a lot of architectural projects, an increase in speed, a decrease in the material costs. We'll see bulk material that's coming out. We'll see, bigger volumes being run. Material costs will decrease. And I think we'll be moving away from concrete. We'll be moving away from cement. So we're very open to switching to a geopolymer, for example, or to replacing sand with recycled aggregates. There are a lot of projects running like this, as there should be. And it's a matter of time before the experience in these areas translates to our type of technology. For geopolymers, we're going to do a project now with a client who's coming in this week as well. She's going to do geopolymer printing. I think geopolymers have a long way to go as well in prefab. It's not necessarily the first step is printing, but I think we're going to move away from cement slowly, at least reduce it significantly, because that push from the market is absolutely there.
What do we need from the world in order to realize those goals? Like what kind of degrees should people be pursuing to participate, or even forget degrees? What kind of things can they learn on their own?
So, as I mentioned, I was happy to see that students from universities are already graduating with skills in Rhino and Grasshopper. I think this visual style coding is going to be popular because I see the potential. It's amazing of what we can do with a visual-based coding. In terms of technology, a lot of the automation engineers, embedded systems engineers that graduate in their courses have a greater focus on, for example, the automotive industry or the aerospace industry or the chip making industry, which makes sense because they're billion-dollar industries, right? But I would like to see these schools also see the potential for construction. So in order to accelerate, we need to push also universities and schools to recognize the future potential of automation in the construction industry. Something you and I recognize and every other person in construction printing recognizes is, the low value added per worker in the construction industry, the aging of the population, there's less sort of willingness to work in the industry. We recognize that, but how do we get young people to see the potential already? It's very difficult to reach such a large market of people. So we need to push that reality at universities in order to educate the new workforce to understand the potential here.
Yeah, I wonder if it's something that can be fostered or something that just people have a natural inclination to be attracted to certain industries.
Yeah, I'm a very bad example of that, of course. I had no technical experience before I started the company. So I had a steep learning curve, which is something I really like. Like steep learning curves are, are fun, they're great. So I enjoyed learning a lot about technology. I just got bitten with the 3D printing bug. The first time I made a small egg cup, I was just sold. Before that, I had no technical experience. One of the main reasons I didn't, by the way, is because the schools I went to didn't have, we call it woodworking in the US, I think. Even though, why is it just woodworking? Why are we not lasering stuff? Like what's going on? Why is it woodworking? It should be much more. We didn't really have a lot of technical education, which I think is so weird. Like, how are we still lagging behind in high school and in middle school on why are there not mini robots and 3D printers and maybe they're there now, right? But when I was in school, they weren't. I went to one school where we were able to make our own PCBs and play with lasers and sensors. But that was just one school out of entire 1 or 2 years of education in that. So I think there's a lack of understanding in the potential of technology because we're not taught it at school either. So I'd like to see more of that. Yeah, more of that.
If somebody had no experience with 3D modeling robots, but they were smart, driven, would you be open to hiring them for like an internship role?
Yeah, definitely. So again, I have a degree in my degree couldn't be more academic. So my degree is in philosophy, which is books, a lot of books, and I loved it. So I don't mind. I know what it's like to have a strange background, academic background. I really don't care what you studied. The most important features are attitude here. If your attitude is right, we'll teach you the rest. I say this to all the interns that join us and all the new people that join us. It's not the quality of the result that I'm most focused on. It's the attitude with which you do it. And oftentimes, you have the saying, you had an A for effort. And we say that with sort of looking down on people that have that, but I think the potential is when we work together. Yeah, it sounds a bit wishy-washy, but when you work together in a group and everybody is working to the best of their ability, you get a well-functioning team. So it doesn't really matter what level the particular person is working on. If they're working at the best of their ability, you see a team multiply just incredibly, right? Individuals by themselves can only reach so much. When you work together, they just multiply. So it's really about, do you have the right attitude? Do you turn up on time? Do you like what you do? Do you try to always improve what you do? Do you add, do you go for that last 10%? Then it doesn't really matter to me what the final product is. It matters how you're reaching that. The rest we will teach you, right? The rest we can teach you. So I'm always constantly trying to keep the sort of the energy level up in the team because look at what we're doing, right? This shit is amazing. So we're always having a good time here, like really trying to push this to the next level. So if you're down for that, I don't care what you studied. If you come with a design background, come join us. If you have a fashion degree, come join us. If you want to do something else, you have a good attitude, we will teach you the rest.
People might be wondering at this point what those pink lights are behind us.
So we're in where we're located now is in an old factory, an old milk factory, and this is actually where when it was first built, where the horse and carts were stationed. When they were still delivering milk, by hand, by cart.
So they would shovel the manure somewhere over there.
I'm pretty sure there's still some feed trays in the back. So they're going to build apartment blocks here now, and we can be in the space. Startups can kind of be here and grow here. And back there is friends of ours. They've started some aquaponics, so they're growing all types of vegetables, and they have 2 big fish tanks. And the feces from the fish are filtered through bacteria, which turn it into nutrients for the plants. And they have a really nice organic ecosystem. So if they add pesticides too, the fish will die, so they can't add pesticides, so they have a nice system. And we are enjoying the orange glow or the pink glow that we get. And the food's local, so it's sold across the street from me. So it's good to be in a space where actually most of the startups that are here in this terrain, you often hear that starting up in a building where there are other startups, so much of the business is between startups, right? And that's even the case here. I've worked with most of the people on this terrain in some project. So it's good to be in a space with other people that are doing innovative stuff like that.
Is that startup culture something regional to Eindhoven or the Netherlands?
So we moved to Eindhoven because before we were in Amersfoort and there was no universities. So in Eindhoven there's a university, technical university, but there are also vocational colleges, several universities. It's the tech hub of the Netherlands. There is the university that does concrete printing. It was one of the early adopters. We have a competitor in France in the Weber BMX factory. So the space here is just, for us, it's easier to grow. We need students, we need people that are interested in technical aspects, so it's easier for us to find people. That's why we're here. Is it unique to the Netherlands? No, probably not. One of the things I do